If you study digital circuits at university, you probably looked at something called Finite State Machine, or FSM. It's a way to describe a system as a group of states and the transition between them, that way defining how the system should operate. This is a very important topic on digital projects, so I want to make a quick tutorial about it. On this first video, I'll give the theory about it, saying what it is and why we use it. And on a second video, I will make an explanation of how we should implement them on RTL. At the same time, I will give some coding guidelines, so you can make a more professional looking code. Well, first, what we need to know is what they are. An FSM is a model of computation, or a MOC. It's basically a way to describe how the outputs of our system are generated from the given inputs. To give a little example, let's think of a vending machine. If you leave it there, it will do nothing, until you insert some coin or press a button. When you press the button, it will check if you have enough money for the can you selected. If not, it will wait more money. If you have enough, it will release the can you selected. You can think of that like a context. Our system will operate on different ways depending on the context is in it. Okay, that's interesting. But the question is why? Why would we use that to develop our digital circuit? FSMs are actually present on the vast majority of digital projects, and that's because the way we usually think about a digital circuit. Generally, we think of some kind of division. We think that the digital circuit is compounded of two paths, a data path and a control path. The data path will be all the portion of our circuit that's responsible for computation. In other words, to receive data and to make some kind of operation on it. You can think of coefficients, of logical operation, or even arithmetic operations. However, sometimes we want to give some kind of control to our system. So the control path will be responsible for that, where we have start, done, or enable signals. So it will not operate directly on the computation, but will start, stop, or do something to manipulate our circuit. And that's interesting. Basically, if you think of the finite state machines, our control path can be exactly implemented as a finite state machine. That way, we can control how the computation of our system will be done. This separation also helps on the modularization of your circuit. If you have some kind of computation problem, you already know that you should look at the data path. However, if your circuit is not waiting some signal, or if it's running while it should be on idle, you probably have some problem at the control path. That way, it's much easier to find the problem and to correct it. That was a quick explanation of finite state machines, and you are possibly a little confused. On the second part of the tutorial, I'm gonna make an implementation on RTL, so things get a little less abstract. Until then, if you have any questions or want to know more about finite state machines, let me know. Send me a message or send me an email. I'm here to help.